Children, we were learning about metals and non-metals. Metals and non-metals. So last class we started with the third chapter of chemistry, metals and non-metals. So chapter starts with physical properties of metals and non-metals, continued by the chemical properties. But before that, you need to know what a metal is and what non-metal is. You know that there are so many elements in chemistry, isn't it? So out of these elements, few are called as metals, few are called as non-metals. So let's see how we are classifying them as metals and non-metals. For example, I take a metal, like I say that sodium. Okay, sodium has an atomic number 11. So you must have learned in grade 9 that the electronic configuration is first shell will accommodate 2 electron, second shell will accommodate 8 electron, and the last shell will accommodate 1 electron. So we have something in chemistry called octet rule. What is octet rule? An element is stable if the last number of electron is 8. So in case of sodium, just observe that last number is 1. It is not 8. So how can you make the last digit as 8? Either by giving 1 electron or by gaining 7 electron. Because by leaving 1 electron, the previous number will become 8. So this is one option by sodium, like either to give 1 electron or to take 7 electron. So see, according to the common logic, it is always easy for sodium to remove 1 electron. So what will happen is sodium will remove 1 electron, and when 1 electron is lost, sodium will get 1 positive charge, Na plus. Okay, so what has happened to sodium is sodium became positive. How does it become positive? By leaving an electron. So we call sodium as electropositive element. Electropositive element. Okay, why it is called electropositive? It becomes positive after leaving electron. After leaving electron, if an element becomes positive, such type of an element we call it as electropositive. And electropositive elements are called as metals. So all the metals will be having plus charges. Like it can have plus 1, it can have plus 2, and it can have plus 3. So we have learned about metals or elements with plus 1 valency, plus 2 valency, and plus 3 valency. Now let's see what the chlorine family will do. Okay, we will take chlorine, and we know that atomic number of chlorine is 17. So according to the electronic configuration, it is 2, 8, 7. Again the problem comes. See, last number is 7. So what are the two possible options of chlorine is either chlorine has to leave 7 electrons or it can accept 1 electron. Okay, so logically which will be easier for chlorine? Chlorine always prefer to gain an electron. Okay, and when 1 electron comes, electron means negatively charged. So 1 electron is coming means it becomes Cl minus. Okay, so what has happened is these type of elements we call it as not positive, it is electronegative elements. Okay, so chlorine is an electronegative element. What is electronegative? It becomes negative by accepting or gaining electron. So electropositive elements, commonly we call them as non-metals. Okay, so it can have how many 1 minus, 2 minus, 3 minus. So it can gain 1 electron, 2 electron or 3 electron. So I hope you understood what is the difference between a metal and a non-metal. So metals are electropositive and non-metals are electronegative. Okay, so these when it becomes like Na plus, it is called as ions, and Cl minus is another ion. So when they come together, what will happen? The ions will combine and give us the salt. All these we will study in detail. So first thing what we have to study in metals and non-metal is their physical properties. Physical properties are properties which you can see directly, like you can feel or you can see, okay, physically how they are existing in nature. Okay, so there are few properties for metals. Okay, we will first discuss about metals. We see that metals are generally hard. Okay, exceptions we will learn later. Second is, we know that there is a shiny coating over the metal and we call that as luster. Okay, we say that all the metals have a luster on them, so it has a shiny appearance. And then we know that all metals are malleable. Malleable means it can be beaten into sheets. Okay, beaten into thin sheets. And then there is something called ductile. Metals are ductile in nature. That means they can be drawn into thin wires. Okay, and the best example or the most malleable metal and most ductile metals are gold and silver. Gold and silver. These are the most malleable and most ductile metal. You know, from gold, from 1 gram of gold, I think 2 kilometer of wire can be drawn. So you can see how ductile our gold is. The remaining properties are most of the metals, they are good conductors. Okay, they are good conductors of both heat and electricity. Good conductors of both heat and electricity. Okay, and the most good conductors, okay, they are used for cooking utensils and all. The most conducting metals are copper and silver. Copper and silver. This is why most of the cooking utensils are made up of copper. Okay, now then you have high melting and boiling points. Okay, high melting point and high boiling point for metals. These are some of the common properties of our metals, that they are good conductors, they are malleable, they are ductile, they are having high melting point, high boiling point, and then when you touch it, like when you hit hard, we can hear sound from it. So we say that metals are sonorous. So these are the basic properties of our metals, and it is easy to remember about non-metals because all these properties are opposite for non-metals. So non-metals are not hard, they don't have a luster, they are not malleable and ductile, instead they are very brittle, they are bad conductors of heat and electricity, they have very low melting point and boiling point, and they are not at all sonorous. Okay, so these are the physical properties of metals and non-metals. Now let's see about the exceptions. Okay, there are so many exceptions in science. Same way, we have some exceptions in the chapter also regarding the property. Like we say that all the metals, okay, they exist in solids, but there is a metal which exists in liquid state. That is exception. What is that? It's the mercury. You must have seen in the thermometer, it is in liquid form. Only mercury is a metal which exists in liquid state, not in solid form. Okay, then we said about the hard nature of metals. Normally all are having like very high melting point. Okay, but there are exceptions, like there is low melting point for gallium and cesium. Okay, low melting for gallium and cesium. These are the two metals who have a very low melting point. Okay, these two metals will melt when you keep it on your palm. That means even the body temperature is enough. Now, iodine is actually a non-metal, okay, but it has luster. It is the only non-metal which has a luster. So, this is one other exceptions of non-metals. Now, coming to carbon, carbon has actually two forms of carbon are there. There are two forms of carbon. We call it as allotropes. What are allotropes? Allotropes have, okay, they are chemically the same. Chemically, both are carbon, okay, chemically same, but different structure. That means physically different. These are called as allotropes, okay. Allotropes are chemically same, but physically different. So the two allotropes of our carbon are diamond and graphite. Diamond and graphite, okay. All the both, when it burn, both gives carbon dioxide because both are carbon. But there are the properties, the physical properties, like diamond is the hardest substance known, but graphite is very soft, okay. Diamond is a bad conductor of electricity and heat, but graphite is a good conductor of electricity and heat. Diamond is extremely very shiny in nature, okay, but graphite is very dull in nature. Okay, so these are some of the properties which distinguishes between the two allotropes. Okay, now the last exception what we need to learn is the alkali metals. What are the alkali metals? Alkali metals are the first group metals. Okay, alkali metals are normally lithium, sodium and potassium. Lithium, sodium, potassium. Okay, these three are alkali metals, but even though they are metals which are supposed to be very hard, they are extremely soft that they can be cut by a knife. Cut by a knife. So that's soft they are. So these are the exceptions we learn about the metals and non-metals. So our physical properties are over. Now we switch on to the chemical properties of metals and non-metals. Chemical properties means how they react with various other elements. Okay, so first we need to learn about how they react with air. That means a reaction with oxygen. Second is how they react with water. Okay, and third is how they react with acids, and fourth one, solutions of other salts. Solutions of other salts. These are the four chemical properties we will be learning in metals and non-metals. Out of that, in previous class we discussed about the reaction with oxygen and water. So let's discuss about oxygen and water first. Okay, so the first chemical reaction is metals reaction with oxygen. Okay, so the general reaction is any metal, when it react with oxygen, it will give you the corresponding metal oxide. Okay, so let's see the general classification, like what are the types of oxides we are going to get. So I just mentioned that metal is M. It react with oxygen. Okay, so as I discussed before, metals are of three valency. We have +1, okay, then we have metals with the +2 and +3. Okay, all are reacting with oxygen, who is a non-metal, whose valency is 2 minus 2 minus 2 minus. Okay, as I said, the variable valencies of metals are +1, +2 and +3. Okay, so what are the byproducts? I mean, not the byproduct, the products what we get when metal react with oxygen is you interchange their valency. Okay, this one will come here and this 2 will come here. This is how we write the corresponding compound. So first we will get it as M2O. Second one, 2 and 2 get cancelled and you will get it as MO. And then when we interchange, you will get M2O3. Okay, so let's write through two examples also for the same. For M2, when the metal is sodium, you get Na2O. If it is potassium, K2O, like that. And hydrogen H2O, like that. Now, if it is 2 valency, For example, copper is 2, so CuO. All these are examples for 2 valencies. And for 3 valency, we have only one metal, which is aluminium. So aluminium is 3 and oxygen is 2. So we get it as Al2O3. So I hope everybody understood that any metal, when it reacts with oxygen, it gives you the corresponding oxide. Okay. So let's see, like all the metals will not react with oxygen in the same way. For example, if it is copper, okay, copper react with oxygen to give copper oxide. So when we balance, we will get it like this. Okay. Now we will learn about a special type of oxide. For example, aluminium oxide, for Al2O3, and zinc oxide. These two oxides are called as amphoteric oxides. Amphoteric oxides. Okay. The peculiarity of these oxides are, normally oxides react with the base. They are basic in nature. So they react with, metal oxides are basic in nature. But these oxides will react with both acid as well as base to give salt and water. So for example, Al2O3 react with HCl to give AlCl3 plus H2O. When we balance, we get this as 6HCl will give you 2AlCl3 plus 3H2O. Okay. But surprisingly, this Al2O3 will react with NaOH also. That means a base also, to give the salt NaAlO2 plus H2O. So what is seen is that, like, there are certain oxides which will react with both acid as well as base to give us salt and water. Those type of oxides are called as amphoteric oxides. And if these metal oxides are soluble in water, we call them as alkali. Okay. So metal oxides, if they are soluble in water, we call them as alkali. So let's see, there are reactivity is different for different metals. Okay. As we see, the most reactive metals are potassium and sodium. They are so reactive with oxygen that they react very violently. So they are stored in kerosene. This is asked by the board, why they are stored in kerosene, because it cannot be kept open, because violently it will react with air and it will catch fire. Okay. Then the next set of metals are magnesium, aluminium, zinc and lead. All these form oxides over it, so that already the oxide will be formed, so further it will not react with air. Then we have, after that comes the metal iron. Iron actually don't react with air, but iron filings, when they are in a small quantities, and if it is sprinkled over the flame, it will catch fire. Then fourth one is actually copper. Copper also does not burn, copper. Okay. But there is a black coating formed on copper. Okay. So this is also least reactive. And the one which will never ever react with oxygen is silver and gold. So this is how the reactivity comes for metals with our air. Okay, that means the oxygen. Now let's see how metals react with the second one. What did we check is the reaction with water. That was the second one we learned. So what is happening is, any metal, when it reacts with water, the first product formed will be metal oxide plus hydrogen. Metal oxide plus hydrogen. And this metal oxide further react with water to give metal hydroxide. Metal hydroxide. side. Here also the reactions are quite different. The order is very different. As usual, sodium and potassium, most reactive. Okay, this will give us the corresponding KOH or NaOH. Okay, and it will release hydrogen gas and that will catch fire. So it's a very violent reaction. Okay, immediately it will catch fire. But the second one is our calcium. Calcium also will give us CaOH twice, okay, plus hydrogen, but no fire. Why no fire is the heat, all are exothermic reaction. The heat released during this cannot burn oxygen, sorry, hydrogen. So hydrogen will form as bubble, okay, and calcium will stick on it. And what we can see is that calcium will float. Okay, both these are happening in cold water. This is also in cold water. But the third one, little more reactive, is our magnesium. Same thing will happen. It will form the corresponding magnesium hydroxide, okay, plus H2, but no fire. And again the same thing, magnesium will float. Everything is same as that of calcium, but this reaction is with hot water. That is the only difference. This is with hot water. Okay, so sodium, potassium, calcium, magnesium, and then we have metals like that group of metals, aluminium, iron and zinc. Okay, they react with not hot water, they all react with the steam only. Okay, but they react with the steam to give the corresponding metal oxide. It will not form metal hydroxide plus hydrogen gas. There are elements like lead, copper, silver, gold, which will not react with water. What are they? Lead, copper, silver and gold. They do not react with water. So we can see that metals reaction with oxygen and reaction with water are different for different metals. Now in next class we will learn about the reaction with acid and reaction with solutions of other salt. Okay, then we will come to the reactivity series.